Welcome my 12th standard warriors to the second session of electromagnetic induction. Today we are going to start with emotional EMF and we are going to talk about Hall effect, what exactly it is and how is it used to actually measure the magnetic field. It's a very interesting phenomena and we are going to solve lots and lots of questions on emotional EMF where you will be seeing when conductors move in a magnetic field, there is an EMF which is developed and that also produces current, and there could be heat losses and also there could be forces involved in there. So all of this with your captain Shreyas. Welcome. Hi Zayed, Archana, PL, Surya, Unknown, Kritika, Archana, Kanishma, welcome Chitra, hello the unknown, hello Shruti, nice to see all of you, hi Devasya, and those of you who are very new out here, please let us know. And remember, the only way you can mark your attendance is when you type and when you interact with me and your fellow warriors in the chat box. So keep the chat box live. At the same time, make sure you are solving the questions, making notes, and do not worry, this lecture will also be recorded. You can replay it again and again for your revision. Also, the PDF for this lecture, whatever slides are there, will be available in the description box as well as the Telegram channel, the link which is there in the description box below. Yes, and you have to smash the like button. Yes, correcto, PL. All right. Hi Dayani, welcome aboard. Welcome. Sir, can negative terminal of the cell be connected to another negative terminal? Yes, you can do that. No problems, Kiran. But it depends whether the batteries are of same voltage or not. If they are of the same voltage, then you will not get anything because both the EMFs will cancel out each other. Okay, so those of you who have developed backlogs, like I can see Unknown Brothers has some big gap. I'm not sure whether you're talking in terms of the portions or something else, but yes, all our lectures are there in the playlist. It's called as the Pathfinder series. The Pathfinder is for the 12th standard batch. That is the students who are going to write the examination next year. I have completed electrostatics, current electricity, Gauss's law, magnetic effects, magnetic sources, bar magnetism, capacitors, and now we are in electromagnetic induction lecture number 2. So, Kanishma, I am from Maharashtra, but right now I am in Bangalore. Hello, Pradeep, welcome aboard. And by the way, in fact, if you want to know more about me, you can follow me on my Instagram handle. And I'm pretty sure you know, I have been teaching for a very long time now, more than a decade. And many of my students are in IITs and any top institute that you can think of, you will have some or the other student of mine. And with this, let me also show you the schedule in case you have missed the first class of EMI that was conducted on Tuesday. Check it out in the playlist. The other lectures were for the 11th standard, and there is a special session coming up soon on Saturday, 7:30. Please remember, 7:30 is my timing usually, so you should keep it in your mind. 7:30, 99% Shreyas sir will be live on YouTube on weekdays. Okay. Before we begin the class, let me tell you about an amazing initiative that Vedantu has, undertaken, and that is, helping all the students who are suffering because of COVID and the situation, and that's, Help India Learn. So there are a lot of students, a lot of kids out there who have suffered because of some loss in the member of the family or loss in the livelihood of the family because of some deaths or because of some illness during this pandemic. So we want to make sure that the learning never stops. Number one, this is an initiative. Number two, on YouTube, we are teaching you guys regularly. So guys, if you have students, if you have friends who cannot afford, then please tell them about the initiative, the link which is there in the description box below. And also, let me tell you, those of you who are, capable enough and, you are looking for some long-term course and you want to get yourself enrolled into a coaching institute and you want somebody who will actually nurture you, who will take care of you, then let me tell you, Vedantu is the one which will actually look after you, because we are giving you VIP, that is Vedantu Improvement Promise. In case you do not improve, paise vapis, you are going to get your money back, and that's what it is. And you can check out all the details, all our results as well. In fact, if I might take a minute or so, you can see till February and March attempt, your seniors, the 12th standard passing out batch, you will see that 1 in 2 Vedantu students were already qualified in March itself for advanced, and you will see 1 in 10 Vedantu students have scored more than 99 percentile. That's amazing. So many students have even scored 100 percentile, and these results keep growing year on year. Last year there were more than 500 students who cracked JEE advanced exam and went into IITs from Vedantu alone. So you can check out all the details of our long-term batches, which are going to start on 9th of August. That's this Monday. So do not forget to check it out, because the course prices are as low as 3,000 rupees per month when you use our coupon code SHHPRO. That's 10%. Hello Ria, hello everyone. PL, if you're stuck with magnetic effects, bacha, it's not too far. Trust me on this. It will hardly take you 4 to 5 days to cover up and reach wherever we are. So guys, please don't let your backlogs expand too much. You need to really buck up now. Okay, chalo. And PL, please first of all take care of your health as well. Make sure that you probably take some good rest after the class and stay cool. Don't take tension. Everything will be fine. Okay. Vedantu, thank you Unknown Krish Bacha, and I'm glad you guys are supporting us and loving us. Hi Kitty, welcome aboard. So Kiran, that's not true Bacha. I will explain it to you in detail. If you want the detailed analysis and help, please ping me on my Instagram handle. Definitely I'll respond, or please leave a comment after the video ends. Okay, so Kanishma, I will come up with a strategy session for all the 12th standard students. Guys, if you want a strategy session, very simple. Share this video, make sure you hit the like button and flood the comment box, not the chat box. After the video ends, flood the comment box. You want a strategy session, a timetable session for the rest 5-6 months or till whenever your exam is. Do let me know, and make sure your friends also attend. Trust me, then I'll conduct a strategy session for all the 12th standard students. Definitely I'll conduct it. Okay, so let's get going. And hello Ankit, welcome aboard. A quick revision, a recap of what we have done till before. In fact, this was a part of our previous chapter. Remember, when you take a charge and throw it in a magnetic field, there is a force due to the magnetic field. And what was the force given by? Remember, it was Q V cross B. V is velocity, B is magnetic field. Okay, so Q V cross B gives you the force acting on a moving charge. You have to use your right hand palm rule to find out the direction of the force. Please remember, Q is a sign sensitive quantity. That means if you have a positive charge, the force will be in the direction of V cross B. But if Q is negative, then the force will be exactly opposite of velocity cross B. Is that understood? Okay, is that understood? Clear guys? Shall we start solving questions? All right, so here is the first question coming up on your screen now. Let's see how many of you can do this. There is a conductor and it is moving with velocity V. Where is it moving? In the Z direction. That means out of the plane of the board. This is a 2D board. You have to visualize in 3D. Okay, it's a cuboid. Height is H, length is L, breadth is B. There is magnetic field in the x-axis. The question is, in which direction will the free electrons, remember this is a conductor, it consists of protons, neutrons, electrons. So in which direction will the free electrons in this conductor experience force, and in which direction will the nucleus of all the atoms out here experience force? Let's see how many of you can get this. All right, Pradeep. Yes, Zayad. Thank you very much. Yes, Kanishma. Hello, Srini, and welcome aboard. Sriya is ready. Ankit is also ready. Come on, think about it. which direction will the electrons experience force, which direction will the protons or the nucleus experience the force. Thank you, Janika Bacha. That's all I want to do. Stay tuned, trust me. I'll not just make physics easy for you, I'll make sure you score really, really well. Okay, that's my aim. That's why I'm on YouTube. I want to make sure that you guys rock the JEE attempt, rock the examinations whichever you are giving. Okay, Abhi saying electron is downwards. Hello Sidhu, come on bacha log, start answering the questions quickly. Okay, in which direction will the electron experience the force and which direction will the nucleus experience the force? All right, so let's start doing the question. So first of all, the formula that I need to use is F is equal to Q V cross B. Now, where is velocity? Velocity is in K cap, that is Z axis, right? So it is K cap. Which direction is magnetic field? Magnetic field is in I cap. Now, quickly think and tell, K cross I, K hat cross I hat is equal to what? In case you have forgotten, just use my rule. Just draw I, J, K in a circle. So, I cross J, K. J cross K, I. K cross I is J. K cross I is plus J. So, the force will be in plus J provided Q is positive. Now, for a proton, understand Q is positive. But for an electron, Q is negative. So, it will be in minus J cap direction. Alright, so for an electron, Q is negative, but for a proton or nucleus, it is positive. So the J cap direction will change. Hence, guys, it's very obvious now for nucleus. Okay, so for the nucleus, which direction will it be? Yes, it will be plus. Yes, I can see your chats. Very good, guys. Most of you have answered correctly. So the force on the nucleus will be upwards, whereas the force on the electrons will be downwards. Excellent if you guys understood this. If you guys have understood this, please let me know by putting up a thumbs up or a yo in the chat box. Now keep this in mind because we are going to play around with this situation again and again, and we are going to find different quantities, different things associated with the same situation. Magnetic field right, velocity towards you, force on the nucleus up, force on the electrons down. Just keep a note of this. We are going to go ahead. Thank you guys for all the thumbs up. Excellent. That's how it is. Yes, that's the answer. Plus Y on the nucleus, minus Y on the electrons. Now look at the same question, but the question says which is the correct representation how the electrons will get accumulated. Because of these forces, you will see some of the faces will get charged. There will be induced charge just because you move the conductor in a magnetic field. You're moving it. So think which of the following diagram is the best way of representing the induced charges. Zayed saying C. Okay. Devasha, can you do one thing, bacha? You can just take our YouTube, live slider behind. You can watch it even in a live class. Just take it. You will see the replay again. Okay. Just do that, bacha. All right. Some of you are saying C. One of you said D as well. Okay. I just told you that, in the previous question that the force on the nucleus was upwards and the force on the electron, all right, on the electron was down. Electrons are negative. So electrons should come down. Protons, positive charges should be exposed on the top. So the electrons from the top will come down below like this. So hence C option should be correct. In D option, it's splitting, it's polarizing left and right. That's not correct, guys. I just told you electrons are pushed down, protons are pushed up in this particular scenario. Obviously, this diagram would be true if the velocity and magnetic field would be in some other direction. So when velocity is here, magnetic field is here, using V cross B, I figured out the separation should happen in the vertical direction. If the velocity was here, magnetic field was here, then if you use V cross B, then the separation will be in some other direction. That's how this works, and hence the correct answer is option C. Okay, everybody clear, I guess? Thank you, Ria. Very good, D. William. Yes. So, Rajesh, if you want my final attempt strategy session, please let me know, bacha. I mean, unless and until you guys put it up in the comments, how would I know what kind of sessions you want? So guys, I am here only for you. Understand, I'm not here for me, I'm here for you, I'm here for what you want. Apart from the long-term series, whatever kind of lectures, if you post it in bulk, then I will get a sense, okay, many people want it, then I will do. If you just put 1 or 2 comments, probably I might feel this is one-off case and I just reply to the comment. So if you have a lot of friends, please let them know, come together, post it in the comments, definitely I will help you out, okay? Don't worry. Okay, now the same situation again, but this time the question is slightly different. The question is, what is the magnitude and direction of electric field, okay, induced due to the induced charges? Okay, think about it. Chaitanya Bacha, do one thing, watch my 12th standard short answer questions micro course. It's there in the pro subscription, Chaitanya GM. See and watch and solve those questions, whatever I discuss in the HC Verma course, and then start doing the HC Verma problems. Trust me, you will be able to do it. And pay attention to the classes regularly. Trust me, it's not that difficult. Go by steps. First solve objective, before that see my short answer questions discussion, then look at the solved examples, then go to small questions in exercise, and then go to the more difficult ones. You will be able to do it. Okay, now how will the induced charges be? Just now I told you that the nucleus will experience force up, electrons will experience force down, so negative charges will be down, so minus is down, and the positive charges will be on the top face. Now the positive charges are on the top face, negative charges are on the bottom face. Electric field should be downwards, right? By chance, I think the answer also came up on the board. So anyways, so this will be the direction of electric field. This will be the electric field which is induced. Electric field is always from positive to negative charge. Guys, one more thing. This diagram somehow reminds me of capacitors. Think about it. Positive charge on the top, negative charge below. Positive plate, negative plate, positive plate, negative plate. Electric field between the plates. Does this remind you about this? Does this remind you about this? Hi Darshan Bacha, come on, join in. Okay, don't worry Pradeep, I'll come up with a strategy session. Let's now concentrate on the session. Yes, Vanakam Darshan. Now comes the next concept. What is the magnitude? See, we were asked two things. Direction done. Now what about the magnitude? Acha, what do we do? How do we find the magnitude of the electric field? Okay, now just think about some electron which will still be there in the conductor. See, there are many electrons. I never said all the electrons will go down. No. All the electrons won't go down. You'll be like, sir, why won't they go down, sir? Very simple. See, there are thousands, lakhs, millions, trillions of electrons. When few of the electrons go down, what will happen? Think, because of the electric field which is created, there will be electric force, right? So a charge like an electron over here will experience electric force due to the field. Which direction will it experience the electric field? Opposite to the field. Remember, if it's a positive charge, the force is in the direction of the field. If it's a negative charge, force is opposite. So to the field. So this will be field and the charge multiplied together. This is the force. Understand? This is the force by electric field. Force by electric field. Where will be the force by magnetic field? I just told you V cross B. If you do V cross B, that will be downwards. I just told you, right? The force on the electron is downwards. And what is the force by the magnetic field? It is charge into velocity into magnetic field. This is force by magnetic field. Now, don't you see, when more and more charges get accumulated, electric field will increase. Electric field will become strong, and there comes a point when the electric field force and the magnetic field force will cancel each other. Hence, the net force on the electron will become zero. So basically what has happened, there comes an equilibrium situation. There will come an equilibrium situation when the force due to the induced electric field will just balance the force of the magnetic field, and that's when equilibrium will occur. So at equilibrium, the force of electric field balances the force of magnetic field. So E will be equal to EVB. E will be equal to velocity into magnetic field. Hence, that's the answer. This is the magnitude of the electric field. As simple as that. Welcome, Krishna. I'm glad you're a new subscriber. Very good. Stay tuned. Trust me, all the portions are going to get completed on this channel. And if you have missed any of our classes before, obviously, please watch our playlist and cover up your backlogs. I'd be really happy to see. Okay. Thank you, Pooja. All right, Zayed says understood. Very good. Yes, Surya, after watching Pathfinder, watch Zero to Hero, but before understanding, do not go to Zero to Hero. That will be dangerous. Okay, never do that. Okay. Yes, Tayyab Asma, I will definitely do that, Bacha. I will do that. I'll conduct a strategy session for all the 2021 students. Let's now concentrate on this. Is everybody understanding this? Everybody got this? This is how you find the electric field? Okay. For the next question, I am going to need it. So what just happened? When you move the conductor, electrons got pushed by the magnetic field down. So they accumulated here. The moment they accumulated here, there was an electric field created. That electric field will create a force. It will oppose the magnetic field's force. And then there will be an equilibrium. And that's when further flow of electrons is stopped. It's arrested, it's stopped. And that's when equilibrium is achieved. And that's how you can find the value of the electric field. Great. Let's get going to the next one. So we just figured out it is minus j cap direction and the value is velocity into b. Very good if you guys have got it. Now the next question. What is the potential difference across these two ends? Beautiful question. Did you see where we started? We started 3-4 questions behind. We started with where will the force be, and finally we are reaching our main goal. What is the potential difference across these two ends? Interesting. Think, I just told you there will be electric field. There will be electric field induced like this. And if this is positive, this is negative, obviously there is going to be delta V, which is potential difference, like a capacitor. There is going to be potential difference across the top and the bottom edges. Just like a capacitor, there is field over here. Electric field is over here. Great. So what is that potential difference going to be? Very simple. Remember, electric field, the magnitude of it is delta V by delta R. Remember this? I have given you this formula long time back in electrostatics. Potential gradient, rate of change of potential with distance gives you the magnitude of the electric field. Exactly. So this field, I just figured it out to be V into B in the previous question, and delta V, I do not know. Delta R is H. So H will come below. So delta V is H, V and B. That's our answer. Harini Prakash, I will do one-shot lectures for every chapter after the syllabus is done, not while the syllabus is going on. Because one-shots are dangerous for a student. All those students who are studying from YouTube right now, using one-shots, you are falling into a big trap. You are ruining your concepts. You are definitely going to face a lot of difficulties, and again after 6 months, 7 months, 5 months, you'll be like, sir, I don't know that concept. Sir, I'm not able to solve that problem. Sir, I'm not able to apply the concepts in the problems. But the people who have patience and who are going to learn it in a systematic way in the long-term series, trust me on this, you're on the right track. People might see, your friends, I'm studying from one-shots. I'm completing the entire syllabus in 15 days. What are you doing? You are completing it by October. I'm doing it in one shot. Gone. Trust me, don't listen to them. You are going to fall in the trap. So one shots need to be done later on, not before the syllabus is done. Yep, don't do that. Okay, chalo. Second equation how? By the way, from this to this was previous slide. This was our previous slide. Remember, I just found this out. Electric field was V into B. I hope you remember that. It was just there in the previous slide. So that was the previous question. Okay, great. Yes, you have 0 to hero. In case you want the one shots, it is always there. 0 to hero, the past lectures are there. So HVB is the answer. Okay, great. Now, Surya, don't worry. Like I said, I will conduct a strategy session for all the 2022 aspirants very soon. Now comes the best part, and that is Hall effect. This is such a beautiful concept. Just observe this. Imagine, just imagine you have a wire which carries current. Imagine you have a wire which carries current, the red one. This is the red one which carries some current. Now, let's say this gray one is the zoomed in version. This is actually not a plate, but imagine it's a zoomed in version. So that is my wire. That is my wire which carries current. That wire has some width. That is some width over here. This is my wire which is carrying current like this. Now you can clearly see that there is magnetic field from the top. Yes, there is external magnetic field which is applied, or maybe it is already present for some reason. Magnetic field which is present externally. Now, because of this magnetic field, there is one interesting thing which will happen. Now look at this, guys. See, when the current is going this way, what actually is moving inside the wire? Is it the protons or is it the electrons? Obviously, protons or nucleus never moves. It's the electrons. So where will electrons go? Electrons will go like this. So strictly speaking, electrons are moving in this direction. Everybody understands this? Electrons are moving in this direction with what speed? The drift speed. Remember, I have told you about drift velocity is the average speed at which the electron moves in a conductor when current is flowing. So that is the drift velocity. Now think about this. When the electrons move and when there is magnetic field, what will happen? QV cross B. There will be QV cross B force, which is the force due to magnetic field. So velocity is here, magnetic field is inside, so V cross B. If you do that, you will see the force coming this way. V cross B will come this way. Velocity is there, magnetic field is inside, V cross B will be here. But since it's a negative charge, I should take exactly opposite of that. So the force on it, the force which is QV cross B, that force will be this way. So think about it. Why, Ankit? Why do we call it Hall effect? Because it was discovered by a guy called as Hall. That's why we call it Hall effect. It's not your bedroom, kitchen, hall. It's not like it was discovered in a hall. No, that's the name of the scientist. Fine. Now that's what you can see. The electrons move here. The nucleus is exposed here. Do you see the separation? Did you just see the electrons moving here? That's what this diagram shows. If everybody is clear till this point, now you will be able to understand why I did those previous questions. It's very similar, this diagram is very similar to the conductor moving in a magnetic field, electrons separating, there will be potential difference. Think, guys, if you measure the voltage across them, you will get the potential difference across it. That's it. So the moment electrons move that side, there will be voltage across, not the length, the width of the conductor. That's the best part. So that's the whole concept of Hall effect. This voltage which is developed across the width is called as the Hall voltage. So what is Hall effect? When current flows in a wire inside the influence of a magnetic field, the electrons experience force and they drift and they collect themselves on one side of the wire. So there is negative and positive charge separation. Because of that charge separation, you will see across the width there is a potential difference created. That potential difference is called as the Hall voltage. Is that clear? Now Ankit, what causes Hall voltage? Exactly this, the magnetic field and the current. So whenever a current carrying wire is placed in a magnetic field, it will experience Hall voltage across the width. Now usually the wire's width is negligible, so the voltage which you see, alright, might not be so appreciable, but understand when you have decent width, you can see that voltage very nicely. Okay, now you might be like, sir, okay, fine, what do I do with this Hall voltage? How is it useful for me? Here is it. If I am able to find the Hall voltage, let's say I connect a voltmeter, indirectly I can measure the magnetic field. So in fact, by reverse calculation, I can find the magnetic field in that region. So this acts like a sensor. This is a device used to measure the magnetic field. You can carry it and you can measure the voltage and you can do some calculations and you'll be like, oh, at this place, this is the magnetic field. Let's do a question based on this. Tanu, you're a little bit late. You missed the fun part at the start. Yes, the separation of the charges in that conductor. So understand, whenever you have a wire, okay, let's say this is wire carrying current, okay, understand if it is a magnetic field like this, understand there will be, okay, there will be negative charges and positive charges separated across the width. This is the width, understand. So they will separate across that. So if you zoom onto that wire, this is my wire, you will see negative charges here, positive charges here, something like this. So there is a voltage difference across the width of the conductor. That's what is Hall's voltage. Okay, Ankit, like I just told you, it is used to measure magnetic field. You can use it to find out where is the magnetic field, what direction, what's the magnitude and all of that. So it's used like a magnetic field sensor. Okay, cool. Let's get going. Yes, bacha, NEET students can also watch it. A Hall effect will remain Hall effect in NEET, in JEE, in boards. Is it important because it is not there in Flash series? Human, remember, this is Pathfinder, this is long term. The Flash series was condensed. So you should always watch right now Pathfinder. Flash series was last year. Now you should watch Pathfinder series, bacha, because those lectures were concise lectures. Okay, let's do this question. Beautiful question coming up on your screen now. See, there is a wire. Okay, there is a wire. The width is 1 centimeter. Okay, let's just call this width. Okay, this width is W, which is 1 centimeter. This is that width, W, 1 centimeter. The cross section is 1 centimeter square. Okay, this is my cross section. You can see that. Okay, so that is basically, let's say I call it area A. Okay, I'll substitute the values later on. Okay, so cross section area is also done. I called it as A. And it carries a current of 1.6 amperes. So let's say I call that current as I. So this 1.6 amperes, I call it as current I. And it is placed horizontally. Yes, it is placed horizontally. And at the pole, that is the North Pole. Now if you remember the Earth's magnetic field correctly, you will remember, you know, the Earth's magnetic field lines look something like this, correct? So if you remember correctly, okay, actually, because at the North Pole, you have the magnetic South Pole, so the field lines will be coming inside like this. Okay, so this is how it looks like. And now if I place this, you know, conductor horizontally, this is what horizontal looks like. So this is the Earth's North Pole, this is the South Pole. Remember, I have told you about this in Earth's magnetism. So at that place, how will the magnetic field look like? The magnetic field will be coming down like this, correct? This will be the magnetic field. Everybody fine till this point? Yes. Now here it is. Yes, now here it is, guys. The next part is, if 1 microvolt is developed across the width, where is it developed? Not across like this, across the width. Then find the value of the magnetic field. The charge carrier density is 10 to the power 23 per meter cube. You will be wondering, why is that given? Don't worry, we'll figure that out. Okay, are you now ready to solve the problem? Let's see how you can find out the Earth's magnetic field just by this information. You have taken a voltmeter. Okay, somebody has just taken a voltmeter and he measured that the voltage across these two ends came out to be 1 microvolt. Just from this value, you can now figure out what's the Earth's magnetic field at the pole. Okay, chalo, let's do this now. First of all, think, same logic. If current is going here, where are the electrons going, guys? If current is going here, electrons are moving this way. That's how the electrons are moving. With what speed? Drift speed. Okay. Now if the drift speed is here, magnetic field is down, velocity cross B. V cross B, guys. Velocity is there. Velocity is there. Magnetic field is down. It's here. Hence, the force due to magnetic field will be there. Check this out. The force due to the magnetic field will be over here, and that will be E drift velocity into B. This is nothing but the force due to magnetic field. Check this out. So V is there, B is down. Electron is negative charge, so flip it. So it's inside. What will balance that force eventually? Because the electrons will shift there will be induced electric field. Understand, there will be electric field. Everybody getting it? Everybody getting it? There will be electric field inside the wire. Why will there be electric field? Because if you look at it from the top, all the negative charges will be here, positive charges will be here. So you can see electric field will be over here. Now once there is electric field, guys, once there is electric field, think what will happen? There will be electric force, and that force on the electron will be in this direction. This is the force by, the electric field. So this is the electric force. And what's the electric force? Charge into the field. Correct? Everybody getting this? Everybody fine till this point? Can we go ahead? Let me know in the chat box if you guys are understanding this. So now once you get this, things are very simple. Remember, I just showed you a question where the electrons won't just keep going on there and accumulating there. There comes an equilibrium point when these two forces will stop cancelling. They will rather cancel each other, and they will stop the further drifting of electrons across the width. So at equilibrium, the force due to electric field and the force due to magnetic field should cancel out each other, and therefore what will I get? I'll get E is nothing but EVB. That's what I'll get. Yes, is that clear? E is equal to EVB. E gets cancelled, so E is equal to, by the way, this is drift velocity. VD is the drift velocity. Okay, is equal to V drift into B. Now field is voltage by width, delta V by delta R. So using del V by del R formula, I will get it as voltage difference, delta V divided by the width. That is equal to drift velocity into B. But hold on, I don't want all these, I want magnetic field. The question is, what's the magnetic field? All right, so we can do that. Magnetic field will be equal to delta V divided by width into drift velocity. Width into drift velocity. Now, do I know the formula for drift velocity? Yes, of course I know the formula. What was the formula, guys? I have told you, current is equal to NVDR in current electricity. I have already told you this. Therefore, drift velocity will be I by NEA. That's the formula for drift velocity. So take these things and substitute it over here and see what do we get. I'll get delta V by W. Instead of drift, you put current, and NEA will go on the top. NEA will go on the top. That's it. Now you just have to substitute the values. What is the potential difference? 1 microvolt. So 10 to the power minus 6. What is N? The charge carrier density, which is 10 to the power 23 into E. What is E? Electron charge, which is 1.6 into 10 to the power minus 19 into area. What is the area? It is 1 centimeter square. So in meter square, it will be 10 to the power minus 4. Whole thing divided by width. What is the width? 1 centimeter, which is 10 to the power minus 2 meters. Current. What is the current? 1.6. So guys, you can clearly see 1.6 and 1.6 will cancel. So you have 10 to the power minus 6, 10 to the power 23, 10 to the power minus 19, 10 to the power minus 4 and 10 to the power minus 2. Check this out. What is the answer that you are getting finally? Finally, what are you getting, guys? Quickly let me know. Obviously, this is not a mains level problem, Chaitanya. This is an advanced level question. Remember, we are mains plus advanced channel. We are not just mains channel, right? Yes. Electron charge is minus 1.6, correct, bacha. But we have already accounted for the negative symbol over here when we showed the forces. Remember, velocity cross B came here, but I actually showed the force there. So it's been already accounted for. And when I wrote this equation, I'm only equating the magnitudes. So all these are magnitudes. So you don't have to put minus sign. It's just like in your 11th standard, you don't put G as minus 10. All right, in the formula for time of light, like 2U by G. You don't put G as minus 10, you put G as 10 because it's already been accounted for. All right, so check this out. Are you getting this as 10 to the power minus 4 Tesla? Yes, the answer should be 10 to the power minus 4 Tesla. Very good, Dharma Teja. Very good, Pradeep. Excellent, guys. I'm proud of you. Proud of you, bacha. Okay, Sanjay, I don't know what is chapter 4, but I am right now on Newton's laws. Okay, so right now on Newton's laws in nurture series. So as soon as Newton's laws is over, then I will go to friction and then I'll go to circular motion and so on and so forth. Very good. Okay, chalo. Let's get going. Now, by the way, 10 to the power minus 4 Tesla is 1 Gauss. So I hope now you saw the application of, Hall's voltage. And this is a very important concept. Now, let's go to the next thing, and that's motional EMF. We just now saw in the previous problems, whenever you take a rod and you move it, there is voltage created across it. So you have a rod and you move it in a magnetic field, you will see there will be potential difference created across it. That potential difference is called as motional EMF. So motional EMF is nothing but the voltage which is created when you take a conductor, move it inside a magnetic field. I just showed you that the electrons drift, all right, and they create potential difference. That's the value of the motional EMF. Now, what's the magnitude of this motional EMF? What's the direction of this EMF? Is very simple. If you have a conductor of length L in magnetic field B moving with velocity V, the formula for the EMF is simply given by L dot V cross B. So let's see, what is this formula? The formula is L dot V cross B. Do you see a dot over here? Okay, and a cross over here. That means this is vector product. This is vector product. This is scalar product. And because two of them are together they are called as scalar triple product. They are called as scalar triple product. Why is it called scalar triple product? There are three quantities multiplied. 1, 2, 3. L, V, B. That's why triple. Why is it called scalar? Why not vector? Simple. You might see, sir, there is scalar, there is vector. Why is it called scalar? The final result is a scalar because you are first doing vector product and then you are taking dot product. So the dot product always gives you a scalar number. That's why it is called as a scalar triple product. Yeah. Now this is the formula you should remember. I know many coaching institutes just give you the formula LVB. Now that's the problem. If you just remember LVB, trust me, you're going to lose marks, because if velocity, magnetic field have some angle, if length has some angle with V or with B, you will be forgetting the angles and those considerations and you will get a completely wrong answer. So in this problem, velocity is here, magnetic field is inside. So if one does V cross B, okay, if you do V cross B, velocity is in I cap, magnetic field is in minus k hat direction, correct? It is in, if Z is towards you, minus k hat is here. So if you do that, where will you get this quantity? I cross minus k, you are going to get it in plus j, right? In fact, you can do it like this also, I j k, I cross k is, minus j, but minus of minus is plus, so you'll get plus j hat. So that's where you're going to get it. Now, whatever is the direction of V cross B, this is also the direction of EMF. Keep this in mind. That means you can replace this rod with one simple battery whose EMF is this value, which is nothing but L dot V cross B. So if you replace it, that's one and the same thing. So whenever you have a moving rod with some velocity, just replace it with one battery of this EMF. That's it. You have already simplified the problem. Yep. So that's how you need to solve it. Now, some of you might be wondering, sir, what about the dot product? It's already been taken care of. See guys, where is L? L vector is in J cap. Now what is J dot? This I cross minus K gave me J. J dot J is 1. So you don't have to worry about it. Length vector and V cross B is also in J cap. So J dot J is 1. So you don't have to worry. Yes, that's how I get it. Okay. So very, very important. L dot V cross B. EMF is always in the direction of V cross B. Keep this in mind. Keep this in mind. EMF is always in the direction of V cross B. Very, very important formula. How to find magnetic field's direction, Farhana? It's very simple. It will be given to you. Okay. Else, if it is not given, other things will be given. EMF will be given, or the direction of magnetic field, if it is not given, current will be given, or velocity will be given. So reverse engineering will give you the answer. Okay. Hello Meghna, join in Bachalo. Now look at this. This is J 2019 question. This is J 2019 question. All those coaching students who did not know it was L dot V cross B failed in this question because they didn't know it was L dot V cross B. So that is why it is very important you remember the correct formula. This was J 2019 question, and the question says there is a rod of 10 meters length and it is from northeast to southwest and it is falling with a speed of 5 at right angles to the horizontal component of the Earth's magnetic field. Okay, and the question is, what is the induced EMF? Okay, what exactly is happening? First, let's draw the north, east, west, south directions. Then let's think about it. Okay, so north is here, east is here, west is here, south is here. Up is towards you, down is inside the board. Think about it. Down, this is down, guys. I am looking at it from the top view. Think you are a bird. Just think you are a bird and looking down, looking at the earth. North is there, east is there, west is this side, south is there. This is up, this is down. So that's the map view or the top view. Okay, cool. Now let's do this, guys. See, how is the how is the wire placed? Northeast, southwest. All right, so northeast, southwest. So this is how the wire is. Cool. How is the Earth's magnetic field? We all know Earth's magnetic field is in south and north direction. So hence magnetic field of the Earth is this way. Magnetic field of the Earth is in the south-north direction. Remember, I'm looking at it from the bird's view, top view. From the top, I'm looking at it. Where is the rod moving? The rod is falling down. That means it is going down. So the velocity is here. See if you guys have understood this diagram. This is very, very important. A lot of people do not understand this diagram and they are going to make a mistake. By the way, if I had to mark this angle will be 45 degrees because that is northeast, this is southwest. Now quickly tell me, guys, if I have to use this formula, E is equal to L dot V cross B, okay? Quickly tell me what is the angle between V and B. Quickly tell me what is the angle between velocity and magnetic field in the chat box. Surya, this is top view. The rod is in the northeast southwest direction, northeast southwest, and it is falling down. That means it is going like this. I'm looking at it from the top. Look, think as if you're on the top of the building. What will you see? The rod falling down like this. So if you look at it from the top, it is falling down. Magnetic field is always in the north and south direction for Earth, standard. No, it is not 45, it is 90 degrees. Look at this, velocity is in, magnetic field is here. Magnetic field is here, velocity is in. So look at the angle, it is 90 degrees. I hope you see that. So this angle is 90 degrees. Correcto. Now where will V cross B be equal to? Where will this V cross B come? Velocity is there. Velocity. Take your right hand. Velocity is there. Magnetic field is here. V cross B. Say where your thumb is going. It's going that side. That's the direction of V cross B. Correcto? Yes. V cross B. No, Dayani, option A will not be correct. Hold on. Be careful. That's why I'm taking up this question. V cross B is there. Now tell me, what's the angle between V cross B and length? What is the angle between V cross B and the length vector? Come on, quickly. Meghna, I conducted a class yesterday, bacha, in the nurture series, and next class will be tomorrow. Yes. So it is 45 degrees, Venki. It's not 135. You can take it as 135, but it's one and the same thing. I'm only interested in the magnitude. So I can just take it as 45 degrees. Is that now clear? Very good. So now my final answer will be L. V cross B will be V B sine 90. That's inside the brackets. And because there is a dot here, remember dot means cos, cross means sine. So this is cos 45. That's what the final expression will look like. Hence, this will be L V B by root 2. Because cos 45 is 1 by root 2, sine 90 is 1. Hence, lot of people would have made that mistake of missing that root 2. That's what will happen. Hence, length, substitute it as 10. Velocity, substitute it as 5. Magnetic field, substitute it as 0.3 into 10 to the power minus 4. Root 2, you can substitute it as 1.414. The answer roughly should come out to be 1.1 into 10 to the power minus 3. Yeah, 1.1 into 10 to the power minus 3 volts. That's how you need to do it. I hope, guys, now you got it. Very good, Bugata Shruti. Proud of you, bacha. Yes, excellent, Anisha. This is such a nice question, guys. Okay. So, happens. Guys, you are allowed to make mistakes. You are kids. If somebody has told you, if your parents, if your friends, your relatives, or somebody else has told you, you are a student, you are not supposed to make mistakes, they are wrong. You can make mistakes, but don't repeat them. Learn from them. It's okay. As a kid, you are perfectly okay. A kid is supposed to make mistakes. Even I can make mistakes. Even I am a kid, I would say, in the journey of life. Every human will make mistakes, but you should learn from it. Understand that. Okay? Chalo, let's get going to the next question. And yes, the answer was B. Yes. Excellent. Yeah, Aryaman, the KVPY crash course has started, but the last batch will start now on Monday. This Monday is the last batch for KVPY SA as well as SX. 2 batches separate in English medium starting on Monday. Okay. So if you want to join the KVPY crash course for physics, chemistry, maths, or physics, chemistry, bio, whatever, you have to check the link which is there in the description box. You'll see KVPY crash course link. Join that for SX. Okay. Cool. Now let's go to the next set of problems. This is amazing set of problems. You have a rod and it is moving, and so many beautiful problems can be made out of this. Look at this question. There is a rod which is moving along the 2 rails. Quickly let me know what would be the EMF induced in the rod. What would be the induced EMF in the rod? All we need to do is use this formula, L dot V cross B. All right. So think, where is velocity? Velocity is this way. All right. So that's minus J cap. Where is magnetic field? That's inside. So that's minus K cap. If you forgot, by the way, minus into minus is plus. So it is J cross K effectively. So I, J, K. So J cross K is I cap. So J cross K is going to give me I cap. Correct? I hope this is clear. Everybody fine? So velocity is here, magnetic field is there, so velocity, okay, sorry guys, sorry, my bad, sorry, it's not J cap, my bad, I'll redo this, sorry, this was L dot V cross B, okay. Now the velocity is minus I cap, not J cap, so it's minus I cap, so it is minus I cap, magnetic field is inside, so it is minus K cap, so I have to do minus I cap cross minus K cap, which is same as I cross K, because minus minus becomes positive. So now if I use this IJK, you will see I cross K will become minus J. So this will become minus J hat. So what does this tell you? The EMF, this rod can be just replaced by one battery like this of EMF E. It will be downwards. Remember, EMF will be downwards, minus J cap. And what will be that value? It will be length. What is the length? Length is, I think, L. And what is the velocity? V. And what is the magnetic field? B. So the answer is LVB. Is that clear? Understood? Is that clear? Munish, if you're joined in right now, I would suggest, highly recommend, please slide that, pointer, that slider of YouTube. Take it to the start and start from beginning. It's better not to miss a concept, because I have, leveled up from the basics to whatever I am right now. Okay, so start from the beginning. Okay, great. So that's the EMF. Beautiful, amazing go. And let's get going to the next part, LVB. Now the same question, but there is a resistance. The question is, what will be the current flowing through it? Guys, this circuit is same as saying there is a resistor. And remember, I just replaced this moving rod with a battery, right? So always think of an equivalent circuit. This is E, this is resistance. What is the value of E? I just figured it out to be BLV. So what will be the current? The current will be like this, and that will be E divided by R, which is BLV divided by R. That's the current. Very good. Munish, if you noodle NCERT level, most likely 60 to 80% you will be able to get it. Okay, because I have done some advanced questions also, so that's why I'm saying, but otherwise 60-80% you will be definitely able to understand. Great. Okay, Ganpati, I'm so glad you finished Gauss law. Please buck up, bacha log. Guys, I'm doing so much of hard work for you. I'll feel very bad if you are not attending the classes and you're not, disciplined enough to, make sure that you don't have backlogs. So please make sure you are up to date, you have minimal backlogs, make sure you are attending the latest class live. If you are watching this recording, please do that. Yep, because it's very important that your backlogs are very low so that you get a lot of time for revision. Remember, this Pathfinder is a long-term batch. I am intending to complete the portions in the next few months, okay, by October or something, the entire syllabus. And then we can start with leveling up the problems. We can do advanced questions and so many other things, and we can practice with mock tests, one shots, and so many other tricks, tips that we have to learn. So guys, you need to really buck up. Please level up your game, okay? Okay, so please do that. Okay, chalo, let's get going to the next question, guys, coming up on your screen now. Yeah, so we got the current, it was clockwise, and the value as well. Now look at the next question. If you move this rod, I just told you there will be a current, and we just figured it out. So this was the resistance R, and we figured out that there is a current which is flowing in the wire. Okay, there is a current which is flowing in the wire, and that current came out to be LVB divided by R from the previous question, and you are moving it with velocity V. Now read the question. Find the force needed to maintain the velocity and find the power. Okay, let's do the first question. Why do you need force to maintain the velocity? Why do you need the force? Let's think. Okay, current is moving, there is magnetic field. Guys, do you remember the previous chapter? When there is a current carrying wire, what does it experience in a magnetic field? Force. What is the force given by? ILB, IL cross B. Do you remember that? Yeah, IL cross B. Okay, so hence, yes, use that concept. So the force due to magnetic field on current carrying wire is IL cross B. Now think where L is below, B is inside, L is below. Use your right hand like this, place it like this, L is below, B is there. L cross B, where is it going? That way. See, your thumb should go that way. L is below, B is that way. Okay, so that's the direction of that force, which is ILB. Now, because this force is opposite to velocity, what will happen? It will retard, it will decelerate. It will decelerate. You don't want it to decelerate. You want to maintain this velocity. That means you need to apply another force, external force. How should the external force be? That external force should be equal to this, so that velocity is constant, that is acceleration is 0, because you want to maintain this velocity. Yes, is that clear? Everybody understanding this? So the current which was produced will experience magnetic field's force ILB that way. That force should be countered by the external force. Only then you will be able to maintain that velocity. So how do I find that velocity out? Sorry, how do I find that force out? That external force will be ILB, right? So it will be just nothing but ILB, but I just figured out to be LVB by R into L into B. So what will this become? It will become, okay, I'll just put it over here. It will become L square B square V divided by R. That's your external force, guys. That's your answer. Yes. Yes, Surya, I put all the answers of whatever questions I give you in the next slide. So when you download the PDF after some time, you'll definitely be able to get it. Okay. Hello Ankita, welcome aboard. Hello Krivify, join in Bachalo. All right, Zayed, you'll get the session PDF within a day. Now comes the last question. What is the power developed? What do you mean by power developed? Power. Why will power be developed across the resistor? Because there is heat loss. Okay, so let's figure this out. Power loss in the resistor. How much will it come out to be? Power loss in the resistor. Just do I squared into R. Just do this. I know it is L square V square B square divided by R square into R. So what will it be? L square V square B square divided by R. So that's the power loss in the resistor. So that's your second answer. You can see that. Beautiful. Yes, that's how it is. That's how it is. Now, there is one interesting thing that I want you to tell you. Interesting thing is, this is the power lost in the resistor. My question is, who is giving the resistor that power? Who is supplying that energy is my question. Yes, the power is getting lost. Who is supplying that energy? If you think, analyze the situation carefully, this rod is moving. Is the rod moving on its own? No. Then who is pushing it? External force. So is the external force doing work? Yes, it is. And that external force is giving that power. Now, if you just do a simple calculation, just multiply. Just forget all this now. I don't need this anymore. Just see what is the power supplied externally. It will be external force into velocity. Power is force into velocity. Remember 11th standard physics. Use this, which is L square B square V divided by R into V. So this will give me L square B square V square divided by R. This is the external power which is supplied. And the best part is that is equal to the power lost. You can see exactly equal. What does this tell you? What does this tell you, guys? This tells me whatever power I am supplying to the rod is completely getting lost in heat. I am doing work, I am pushing the rod, I am doing mehnat, I am pushing the rod, and that energy is getting lost in heat across this Kamina resistor. That's what is happening. Okay, so rock and roll, I'll do it, bacha, after some time, but let's now concentrate on the Pathfinder plus also on the next JEE Mains attempt, and whatever questions we get from the actual NTA website, definitely we will try to make some session out of it. Okay, don't worry, rock and roll. How heat is lost? Because of the current. Whenever current flows through resistance, remember, heat is produced. It is heat loss, I squared R losses, Joule's law of heating. Okay, so that's how you get it. Okay, Afaf, yes, bacha, I do remember you. Come on, let's get going to the next one. This is also a beautiful question. Amazing question, guys, coming up on your screen now. Okay, so the question is basically, there is a wire which carries current. There is a loop over here, and that itself is moving. The question is, what is the EMF? Okay, what is the EMF produced? Now, I'll tell you what you can do. This is actually a motional EMF problem. Just tell me one thing. If I mark these points, let's say P, Q, R, S, can you see there will be some rods under the influence of magnetic field which will produce EMF? Now you'll be like, sir, where is the magnetic field? Don't you see this wire carrying current? Use your right hand rule. This current carrying wire will produce magnetic field around it. There will be circles, concentric circles. And due to a long straight wire, we already know what's the magnitude of the magnetic field due to a long wire. Now when you are here close by, the magnetic field will be very strong, okay? It will be very strong. As you go far away, the magnetic field intensity will reduce. What is the magnetic field as a function of X? We all know that magnetic field is mu naught I by 2 pi X. That's the formula. However far you are, mu naught I by 2 pi X. X is the distance from the wire. That's the field. And as you go far away, you will see that the field will reduce. Great. Monish, if there is some doubt which is not solved, please let me know in the comment section after the video. Definitely I will solve it. Hello McGomer, hello Madhuri, hello Abhilash Ray, hello Sriram, hello everyone out here. Okay, join in Bachalok. We are almost midway in the lecture. Now think magnetic field is inside. Out of PQ, QR, RS and SP, which parts of those wires will experience EMF? Remember, EMF, for the formula of EMF, L dot V cross B. That's the formula I have to use. Guys, this part, which is PQ, is moving there. Velocity is there. Magnetic field is inside. V cross B is here. V cross B is here. Any part which you take, which is moving that way, velocity cross B is here. So EMF will be produced only in this direction. Only in this direction, not in this direction. V cross B is here in y-axis. So QR and PS will not produce any EMF. Understood? Along their length. Along their length, they will not produce any kind of EMF because velocity cross magnetic field is over here. So only PQ and SR will produce EMF, but out of that also, PQ will produce more EMF. Why? Because it is closer to the wire and the magnetic field B is strong. So this will be a stronger battery. This one over here will be a weaker battery. I hope this is clear. Hence, now think it's like two batteries in opposite direction. So what will be the net EMF in the loop? It will be EMF from the closer one minus EMF from the farther one. Is that understood? Or think of it this way, it's nothing but EMF because of PQ minus EMF because of SR. That's what it is, because PS and QR did not create EMF. Now what you need to do, just substitute the values. What is EPQ? It's length into velocity into magnetic field at this point. What is the magnetic field at this point? Let's say, I don't know, but I'll just put it as X, let's say. So I'll just put it as mu naught I divided by 2 pi X. Okay, from the wire it's at a distance of X. Minus second EMF will be again L V mu naught I again divided by 2 pi. That X will be different. Okay, maybe I can call it as maybe X2 or something. I can call it as X2. So that's what I'll get. And you can see so many things are common, like L is common, V is common, mu naught is also common, I is also common, 2 pi is common. The only thing which is not common is 1 by X and 1 by X1. Now it's just a matter of substitution, guys, you will get it. Okay, so you just substitute everything and you will get it. Okay, so Abhilash, probably if you start from the start of the class, maybe you will be able to get it, because I have explained motional EMF in detail. So start from the beginning, because midway it's little bit difficult. Yes, Ankit, I do remember you joining Bacha. Yes, Lillian, Rasu, I'm not sure, probably you should attend my classes regularly. All right, so just substitute. So what is the value of length? Length is 0.1. What is velocity? Is the velocity given? It is 10. Mu naught by 2 pi. Okay, that will be 2 into 10 to the power minus 7. Okay, 2 into 10 to the power minus 7. And current, is the current given? Where is the current? Yes, it's 1 ampere. So into 1 and 1 by X. What is X? I think X is 10 centimeter. So it is 0.1 minus X1 or whatever that, X2, my bad. X2 will be 10 plus 10, that's 20 centimeter. So this will be 0.2. Just solve this, you will get the answer. 0.1 into 10, 1. And this will just become 2 into 10 to the power minus 7, I guess. And what will you have? 1 by 0.1 is 10, 1 by 0.2 is 5, 10 minus 5 is 5. So it will be 5. So it will be 10 to the power minus 6 volts. Okay, yes, that is 1 microvolt. That's the answer. Beautiful question. Did you love it? No, it's not A. It's not A. Okay, chalo, let's get going. Thank you, Vikas. Yes, Dayani, it will be B. Correcto. Such an amazing question. These are the kind of questions you should expect. Let's quickly move on to the next question coming up on your screen. And yeah, before I go ahead, oh my God, Achyut, please message me on Instagram and don't do all this, yaar. Matlab, Achyut, I don't know how do people think of all this, yaar. I mean, like, okay, I'll respond to you, Achyut. Okay, sure, I'll respond to you on Instagram. Okay, so by the way, those of you who are interested in solving more problems, who want solved examples, chapter summary and mind maps and previous year questions, this is the book you should refer to. This is called as the Tattva module. This is the book which every topper is referring in Vedantu right now. And this has got everything. These are unit wise. They are available for physics, chemistry and maths. You cannot buy it on Amazon or on a local bookstore. Only when you are a part of Pro subscription, you will not only get the hard copy but also the soft copy for your reference. So that's Tattva material, which is Vedantu's own study material. Okay, going to the next one. Yes, Ankit, I do refer to Tattva as well. Obviously, I'm a Vedantu master teacher. I use Tattva myself. Okay, now next question. There is a rod which is rotating. There is a rod which is rotating about the center, and the question is, what is the EMF developed across it? And there is magnetic field and all of that. I'll draw the diagram. I'll spare you reading all these things out here. So there is a rod. It is rotating with omega. The length is L. Okay, this is the rod. Okay, and the question is, if the magnetic field is like this, for example. Okay, this is the magnetic field. The question is, what is the EMF developed across it? Now, whatever result I give you, please remember it. This question comes many times and you will see the result useful in many scenarios. Now, to find out the total EMF, I cannot do EMF is LVB. Reason? Each point on the rod has a different velocity. Each point on the rod has a different velocity. How? Check this out. If I take a point at a distance x, okay, let's say this section, this small element has a width dx. The velocity of this point or this section over here will be omega x. Remember circular motion, omega r, v is omega r. So every point has different velocity. So actually speaking, every section will develop EMF. So the total EMF has to be found out by adding all the EMFs. Think these are small batteries and you have to add all the EMFs to get the total EMF. I hope this is clear. So hence the total EMF will be integral of d. Each element will produce d EMF and that d will be L, but L is not total length, L is the length of this. What is that? That's dx into velocity into b, and this will go from 0 to L. From 0 to L, all the elements needs to be added up. Correcto. Hence, just do that. So before that, just substitute the value of velocity. What is it? It's omega into x, right? So omega b and x dx will come over here. This is 0 to L, so this will become omega b. Integral x dx will be x square by 2, and from 0 to L, so this will become half omega b L square. That's the EMF. Now just substitute all the values and you will get the answer. So this is something which you should remember, half omega b L square. Remember this, very useful, very useful. This will give you the answer instantaneously. It will spare you the time of integration. Okay, just substitute it. I'm pretty sure you will be able to get it. You'll be able to do that. You'll be able to substitute. Come on guys, let me know in the chat box if you guys will be able to substitute it. Let me know in the chat box quickly. Okay, Psycho Girl says A, yes Zayad, yes JV Pradeep, all right Nikhil, excellent. Let's get going to the next question. Now, yes Vikas, there will be a session on mechanical properties of liquids and solids, but that will come very later in the nurture series. But if it's urgent for you, you can check it out from my flash series, which is there again in the playlist. But for the nurture series, you'll have to wait for some time because the order of the chapter is very important. Now, there are two important tricks I will give you guys. And the two important tricks are, when you have a curved wire and that curved wire moves in a magnetic field, to find the EMF, you don't have to sit and integrate, just replace it with a straight wire. That means just join the ends and then replace it with a straight wire. Whatever EMF will be produced in the straight wire will be the EMF in the curved wire. Remember, the same rule was also there in the previous chapters, where force on a curved wire was same as the force on a straight wire in magnetic field. So same thing is also true over here. Okay, this is very important, and remember, this rule is only applicable when the magnetic field is uniform. If it is non-uniform, you have no other option but to sit and integrate. Okay, that's how you need to do it. It's very useful trick for all of you. The second trick is this one. If there is a loop, if there is a complete loop, guys, what's the start and the end of a loop? See, if there is a curved wire, you used to replace it with a straight wire. If it's a loop, starts here, ends here, what will you replace it with? With a dot. The effective length will be 0, hence the EMF is also 0. So in a loop which is moving in uniform field, the net EMF is always 0. Okay, so that's how you get it. So if you want the proofs, I've discussed these proofs. I mean, there are, simple ways of proving this. Like, look at this. When this loop moves, the flux through it remains constant. So the flux remains constant by Faraday's law. By Faraday's law, understand, EMF should be 0. Faraday's law is anyways valid. Yes, Dayani? Correct? So hence the EMF should be 0, as simple as that. Because the loop is here or there, the flux through it is always the same. Hence it will never change. So that's how you can do it. Okay, let's do a question based on this. Very straightforward question coming up on your screen now. So there is a wire which is bent like this. I hope you can see that wire. It is bent like this. The question is, what is the EMF produced across that wire? Okay, it is moving like this with some velocity. What is the EMF produced across that angled wire AOB? That's the question. Use our technique. What was our technique? Curved wire. Curved wire can be replaced with a straight wire. With a straight wire. So just join the ends. Just join the ends. That's my straight wire. What will be the length of it? That's not difficult to find out. Just drop a perpendicular and think, what will this angle be? This will be theta by 2. Correct? This will be theta by 2. Now, in this right angle triangle, L is the hypotenuse. This is the opposite side to theta by 2. So what will this side be? This will be L sine theta by 2, right? This is a right angle triangle. This is hypotenuse. Opposite to theta by 2 is this one. Hence, the complete length, the effective length will be this plus this. Each one of them will be L sine theta by 2. So it will be 2 times of L sine of theta by 2. That's the effective length. Correct? Now, here is the simple thing. The simple thing is, what will be the effective EMF? The EMF will be nothing but L effective into V into B. Length is perpendicular, magnetic field is inside, velocity is also perpendicular. So sine 90, cos 0, all of those things will give you 1. So L effective is 2L sine theta by 2 and velocity into B. Hence that's the answer, guys. As simple as that. Okay, so that's how you need to do it. JV Pradeep, nobody knows when the result is going to come, just wait for it. Hivaman Swami, you need to prepare using our mock tests, but we won't have special classes for individual CETs because there will be so many CETs, otherwise it will be very difficult to conduct those classes. So we are more specific towards JEE, let me tell you that. JEE, BITSAT and all of that. Okay, so you can see that's the answer, guys. Using our simple rule that a curved wire can be replaced by a straight wire, as simple as that. Okay, let's get going to the last question for today. It's an amazing question. Okay, now look at this. There is a loop. It enters this region of magnetic field and it comes out. The question is to show the direction and probably the magnitude of current as the center of that wire moves. As the center of the wire moves. Okay, here is the thing. This loop, when it is completely outside the magnetic field, okay, when it is completely outside the magnetic field, will the flux through it change? Let's say it moves from here to here. Will the flux change? Come on, quickly my warriors, answer. Okay, think about it. Will there be flux change? No, right? There will be no flux change because this is outside the magnetic field. Remember, the magnetic field is only present here. Okay, the magnetic field is only present here. I hope this is very, very obvious. Okay. Now, here is the thing. Imagine the magnetic field, okay, anyways, was like this. For example, this is the magnetic field. It's inside. As this loop reaches here, that's when the magnetic field will start entering in the loop, because as soon as the loop goes over here, you will see there is this rod which is inside the magnetic field, and using velocity cross magnetic field, my thumb goes up, you will see I can replace it with a battery over here. So till the right edge reaches here, there is no EMF. Okay, so till the right edge reaches over here, there is EMF is 0, but the moment you see this going inside, there is EMF developed across it. The current will be like this. Make sense? Yes, so the flux starts changing. Now there will be EMF till the left edge reaches here. You will see there comes a point when the complete loop is inside, and now once the entire loop is inside the magnetic field, now understand the flux will be constant, and because the flux is constant, the EMF will be 0. There will be no EMF developed across it. So here it is, till this point nothing, because it's outside the field. As it enters, there is flux change, EMF developed across it. How did I get this direction? Velocity cross magnetic field will be here. So this right edge will produce EMF this way. Okay, that's how the EMF will be. Once this is completely inside, that's it. There will be no more EMF till this edge reaches here. Okay, so till this edge will reach over here, there will be no EMF. Again after this, as it exits, you will see there will be EMF produced, but this time this will be the battery, so the EMF will be produced this way. Think about it, it will be produced that way, and this will be there till this edge comes out completely, and you see the loop is completely outside the magnetic field. Once it comes outside, the EMF will become 0. So you can see, divide it into stages. While it is entering, any part is inside, EMF is there. Once completely inside, no flux change. While exiting outside, again EMF is there, and while it is going outside, after it is outside, again there is no flux change, it's completely outside, 0 EMF out there. So basically, if you think the midpoint, okay, the midpoint is at a distance of minus 3L/2 over here. Okay, so that's when the EMF begins to produce itself till it is just completely inside, and when it is just completely inside, you can see the center of the loop is at a distance of minus L/2. So from minus 3L/2 to minus L/2, EMF is produced. Again after that, nothing, and the same thing will be repeated on the other side. So from plus L/2 to again 3L/2, EMF will be produced. So in this region and in this region, EMF is produced. Everywhere else, it is not produced. As simple as that. Okay, so if you have to look at the simulation, this is how it looks like. This is very beautiful. Look at this. You can clearly see what is happening. It enters, the flux changes. Once it is inside, no flux change. The flux remains constant. This red graph shows you the flux. Okay, the red shaded area tells you how much area is there inside. So it remains constant once it is completely inside. Only while entering or only while exiting, there is current which is generated. I hope this is clear. Okay, so there are 3 homework questions for all of you. This is your first homework question. Okay, this is your first homework question. This is your second homework question. Okay, put up all the answers in the comment section. And this is your third homework question. All 3 homework questions are based on motional EMF. And remember, if you want to improve your ranks and results and you want to have a long-term course with us, there is pro subscription which is available in the description box below. There are all the 3 versions, light, classic and plus, which will offer you different benefits. The course prices are as low as 3,000 rupees and you get 10% off with my coupon code SHHPRO. So that was the lecture, second lecture of motional EMF of electromagnetic induction, which is very, very high weightage. Thank you guys for tuning in. This was Shreyas here. Stay safe, stay tuned. I'll continue this chapter next week again. Till then, bye bye, take care, hasta la vista.